All right, today in class we're going to be covering lesson 2-3, and today is just day 1 of that lesson, so we'll continue it tomorrow. But we're going to continue with the same learning target. We're going to be solving one-step and multi-step equations today, focusing on the multi-step equations being more than 2 steps, so 2 plus steps with one variable, so one type of variable. If you look at the first example, we have the problem of 5 is equal to 5m minus 23 plus 2m. I want you to write down this example. When we're looking at this example, we have the variables showing up in multiple places. Because they're showing up in multiple places, the first thing we need to do is simplify what we can. Okay, so when we simplify, we're looking to do order of operations, so the typical PEMDAS, which includes combining like terms. It also includes any distributing. When it appears. Okay, so that's the first thing we want to do. We want to simplify what we can on one side of the equal sign. So if we're just looking to the right over here, this side of the equal sign, we have 2 terms that have m's. We have a positive m, positive 5m and positive 2m. So before we go on, we want to simplify that. So the left side stays the same. 5 is going to be equal to, and then we want to combine them. 5m and 2m gives us 7m minus 23. Now that we've combined any like terms, there's nothing else on this right side of the equal sign that we can simplify. And there's nothing on the left side that we can simplify. So from there we go to step 2, where we're trying to isolate the variable. And when we want to isolate a variable, we're going to be using SADME. So now we're using our inverse operations. And our properties of equality. So when we look at this, we're subtracting 23, starting with addition and subtraction, we're going to add that 23 to both sides. That'll cancel out, giving us a value of 0. So then we rewrite where we're at. 5 plus 23 gives us 28. Then it's equal to 7m. This is multiplication, so to show division, we show our fraction bar line dividing by 7 on both sides. That gives us a value of 1. 7 divided by 7 is 1. Equal sign comes straight down. The variable stays on the same side, and 28 divided by 7 gives us 4. We can always plug it in again to make sure that it works. So if we do that, we would have 5 is equal to 5 times 4 minus 23 plus 2 times 4. Simplifying the multiplication, we get 20 minus 23 plus 8. And then just in order from left to right. So 20 minus 23, that's going to be a negative 3. Then plus 8, which is exactly what we needed it to be. So we know that our answer was correct. Let's do some practicing with that. Again, we're going to simplify using PEMDAS and then isolate using SADME. So if we look at the first example, we have 11m minus 8 minus 6m is equal to 22. The first thing, again, we want to do is simplify, combining any like terms. So looking at the left side of the equal sign, we have a negative 6m and 11m. It's owning the sign in front of it. Nothing should be left over. It's a negative 6. So when we combine them, 11 and negative 6 combined together gives us 5m. And then we're still subtracting 8 is equal to 22. We've simplified as much as we can using PEMDAS, combining like terms, and distributing. There's nothing to distribute, no parentheses, so now we can go into isolating. So at this step, we want to isolate. So we're going to use inverse operations, adding 8 to both sides of the equal sign. That gives us a value of 0 and cancels out. leaving us with 5m is equal to 30. Now we use division on both sides, giving us m is equal to 6 for our final answer. The next type of example we're going to use still uses these exact same steps. But you'll notice this time we're going to have to use the distributive property because we have parentheses that we need to get rid of. So I'm going to rewrite it so it's a little bit easier to see. So we have -8 multiplied by the group of 2x minus 1 equal to 36. Starting first by simplifying, we're going to distribute and multiply the 8 in. -8 times 2x is going to give us -16x. -8 times this -1 is going to give us a +8, showing that sign is equal to 36. So we've distributed to both terms, taking into account the signs. A negative and a negative give us this positive. So now we're going to go into the step of isolating using SADME. So we're going to subtract 8 on both sides. That'll cancel out because it's a value of 0. From there we have -16x left. When we subtract, we get 28. And now we need to divide by a -16. -16 divided by -16 gives us the 1 we need. So now we have 1x, which can be written as just x, is equal to 16 doesn't go into the 28 nice and evenly, so now we need to divide it or simplify. What may be easier to do is to show that we're simplifying this fraction. 28 and 16 are both divisible by 4. So that's what we're going to divide them by. 28 divided by 4 gives us 7. -16 divided by 4 gives us -4, and now it's a little bit easier. We could leave it as -7/4, but for now, let's rewrite it as our mixed number. It's still going to be negative. 4 goes into 7 one time, and 7 minus 4, we would have then 3 left over. So that would be our answer. Let's try the next example. This time we have the problem 18 is equal to 3 multiplied by the group of 2x minus 6. So again, our first step is always going to be to try and simplify each side of the equal sign respectively. So if we look at the right side of the equal sign, we have parentheses. In order to get rid of those parentheses, we need to distribute. So we're going to do that, leaving us with 18 is equal to 3 times 2 times x gives us 6x. 3 times this -6 gives us -18. And we've distributed it to both terms. Now we don't have any like terms to combine. And we don't have anything else to distribute. So now we're going to go into isolating using SADME. We're subtracting 18, so we're going to add 18 to both sides. That'll cancel. 18 plus 18 is going to give us 36. That is equal to 6x. So when we divide by 6 on both sides, that'll cancel, leaving us with 6 is equal to x. The equal sign comes straight down, and so does the x. And that would be our final answer. So our answer would be C in this case. Sometimes the problems that we're working on are going to have fractions. Just because they're fractions, we still use the same process. We want to simplify using PEMDAS, and then isolate using SADME. So if we look at this example, we have 3x over 4 minus x over 3 is equal to 10. That's one way of writing it. Another way is saying, well, we can pull the fraction out and still show that we're multiplying by x, because you'll notice that the x is in the numerator, meaning we're multiplying it and then dividing by 4. So the other way of writing this problem is by saying we have 3/4 x minus, there's a 1 in front of the x, minus 1/3 x is equal to 10. Either way is fine, and you'll see that other strategy written down here as well. Okay. Method one way of solving it is to write like terms using a common denominator. So that's what we're going to do right here. So if we're doing that, to get a common denominator between the 3 and the 4, I'll multiply the first fraction by 3. And multiply the second fraction by 4. All we're doing here is rewriting the fractions. Because we're doing it to the numerator and the denominator, they would cancel out, so it's not changing the value of the fractions, we're just rewriting them just like we would any other fraction. And then we'll write what we get underneath that. So 3 times the 3 gives us 9x in the numerator. 4 times the 3 gives us 12. Again, 9/12 would simplify to be 3/4, so it's the same value. Minus, up here we'll have 4x over 12. Again, 4/12 would simplify to be 1/3. So it's the same thing. And then what we can do is rewrite that as a fraction as well. So now, getting that one also as a common denominator. Well, actually, we'll wait on that. We'll still keep that as 10 for now. You'll notice here that we have two terms that have x as the variable. So they are like terms because they're both being multiplied by x. So now we can simplify. 9x minus 4x, or 9 minus 4, gives us 5x over 12 is equal to 10. What we're going to do is rewrite this 10 by putting it 10 over 1. And now we're not dealing with any addition or subtraction. So we don't need a common denominator, but we are dealing with a fraction. And we talked about how the way to simplify this would be to multiply by the reciprocal. So we would show 12 in the numerator and 5 in the denominator. And that's going to go on both sides. 12 in the numerator, 5 in the denominator. Five, 12 times 5 divided by 12 cancels, and the same thing here. So because they're diagonal, we would get 1 over 1, so that goes away. And what we're left with then is x is equal to what we get when we simplify. Well, we know that we can go diagonal to simplify. 10 and 5 can both be divided by 5, bringing that to a 1 and bringing the 10 to a 2. So now when we simplify, it's just going to be 2 times 12, which is 24, over 1 times 1, which is really just 24. Okay, so that's one way of simplifying. Here's another way. You'll see that method 2 is saying that we're just going to clear the fractions from the equation. So in order to do that, what we want to do is multiply by the least common denominator between the two. So if we're looking at the 4 and the 3, what we would need to multiply by on both sides of the equation would be 12. Our least common denominator, or in other terms, our least common multiple, is going to be 12. So we're going to multiply by 12 on both sides. What that'll look like, and what your work needs to show, is that we're multiplying it by everything in the equation. So we're going to show 12 over here, and actually 12 on the right side of the equal sign as well. So now, when we do this, we're saying that we have 12 times 3. We'll put 12 over 1. 12 times the 3/4, and then we're going to divide it by 4. So 12 times 3 gives us 36, divided by 4, simplified gives us 9. So that's the first term, giving us 9x. We'll put our subtraction sign, and then we have to distribute it to the second term. So we'll show that here. Again, 12 over 1, and we'll multiply by 1/3, giving us 12 over 3, which is 4. So this time, after we distribute it, we still have to multiply by x, so it's going to be 4x. And that's going to be equal to what we multiplied over here, which is 120. Now when we simplify, we have like terms. 9x minus 4x is 5x is equal to 120. If you look over here in the numerator, we have 9x minus 4x. That matches. Again, if we were to multiply this part across, the 10 times the 12, that would give us the 120 we have. So they look very similar, and we should get the same exact answer. So now when we divide by 5, that'll cancel. And if we're unsure, we can always say topsy in the boxy, 120 divided by 5. 5 goes into 12 2 times, giving 2 left over. We bring down the 0. 5 goes into 20 4 times, exactly clean. So our answer then would be 24, which is exactly what we had before. Again, 2 different ways of solving it. Either one of them is fine. It's helpful to be comfortable with either strategy. I would say this first strategy, if you are comfortable finding the least common multiple or the common denominator between the fractions, that would be a great strategy, because then you can get rid of the fractions altogether and work with an easier expression. The 9x minus 4x is equal to 20. However, finding common denominators is also a great way to simplify it. So you're choosing the strategy that's going to make the most sense to you, and get some practice with that. We'll continue practicing and asking questions as we go through.